Welcome to Lab Life with the Air Force Research Laboratory.
Hi, I'm Michelle.
And I'm Kenneth.
Hello, folks. Today we are unveiling our new Lab Life segment, Lab Bites, short bite-sized looks into topics that didn't make it into a feature-length episode. Starting it off, we're joined by Dr. Joanna Hinks for some GPS 101.
In 3, 2, 1.
We're here with Dr. Joanna Hinks from the Air Force Research Laboratory. Welcome to the podcast again.
Hi.
So today we really want to know, you're an expert in GPS. Can you give us a 101? Because some people might not even know what GPS stands for.
Sure. So GPS, you hear that those three letters stands for Global Positioning System. So what GPS is 31 satellites that are orbiting in medium Earth orbit, which means that they orbit the Earth twice every day. And then you have what we call a control segment, which is a station on the ground with a lot of antennas that tracks where the GPS satellites are and then sends messages up to them to tell them what to broadcast. And then you've got all of your user equipment, for instance, your cell phone or your car. And all of those things have to work together in order to tell you where you are on the ground.
That's incredible. Thinking about that system all working in place then. So there's enough satellites, the idea is no matter where you are, what time you're using this, you should always have coverage.
Exactly. So in order to figure out where you are on the ground, you need to have at least 4 GPS satellites in view at a given time.
Oh, wow.
So the way that GPS works, it relies on physics. Imagine that. So we know where those satellites are really, really, really accurately. The satellites are about 20,000 kilometers away from the user at any given point. 20,000 kilometers is really, really far.
That's a long way.
And we know where those satellites are at a given instant in time to within about a foot.
Oh my gosh.
Wow.
So we know those satellite orbits really, really well. And what we do on the ground is we calculate how long it takes for a signal that's broadcast from the satellite to get to you. And then we use the fact that the speed of light is very well known and figure out how much distance was there if it took that long to transmit.
And you said since you have to have at least 4 satellites above you to triangulate, do you bounce a signal between all 4 of them, or is it just they have a fail-safe in case just really one bounces off and one works to find you?
No, it's not a fail-safe. So what happens is that we've got a range from the satellite to the user, and we need 4 of those. So each one you can think of, if I know that you're a distance of 20,000 kilometers away from me, that means that I'm sitting somewhere on a sphere that's got a radius of 20,000 kilometers. Well, if I had 3 of those, in theory, I could find where those spheres intersected and figure out where I am. But there's a catch because that depends on knowing when I am, since I was measuring time to find my range. And if my clock isn't accurate to a nanosecond, and a nanosecond is a really short amount of time, that's 1/1000th millionth of a second.
Jeez.
If my clock isn't accurate to a nanosecond, then I don't have accurate position. So that 4th satellite is needed in order to figure out the time that I got it. It basically adds a bias or an unknown range to each satellite range, but that's the same for all of them because it's dependent on the same error in my clock that I have in my device. So do a little bit of math and you can back out your position in X, Y, Z, or latitude, longitude, altitude, and time.
I had no idea the 4th is used for time. That makes sense.
That's what it is.
Wow. Yeah,
so actually, many of the most important applications of GPS don't care about position. They already know where they are. They just care about getting very accurate time. So, for instance, financial transactions are time-stamped with GPS.
Okay, I didn't know that.
I had no idea. But, I mean, when you think about, I guess, trading, I mean...
High-speed trading, yes.
Wow. Because that could be, depending on what scale you're trading, that could be
A lot of money.
A lot of money. A lot of money.
And you ever think about GPS, like what it's used outside of for navigation or again position, like you mentioned? I have no idea.
Yep. Yeah, so financial transactions, is also used to time the power grid that we all rely on, to make sure that all the power stations stay synced together properly. It's also used for keeping time very tight on cell phone transmissions. So a lot of places that you're using it every day and you didn't even realize.
Oh, absolutely. I never thought about the stock market or anything like that.
Yep.
Or financial transactions.
Yeah, it shows just how important GPS is, and like we talked about the NTS3 beforehand, how important it is to keep those signals strong and, uninterrupted.
Exactly.
Awesome. Well, any other things that you want to, maybe any rumors or misconceptions about GPS you'd like people to know?
Sure. So
I mean,
a couple.
a huge part of your life was like studying GPS, right?
So I've been studying this for a number of years now. So, a couple misconceptions. The GPS satellites cannot track you. It's actually a one-way transmission from the satellite to the user. So the GPS satellites don't know where you are. They're just sending out their signals to everyone, and you're receiving them. A GPS tracker.
You can take off his foil hat now.
Okay, good.
You can take off your foil hat, yes. So a GPS tracker means that it's something that's computing your position on the ground and then sending it out over a secondary link to someone. Okay. Yeah. So
good to know.
They're not tracking you. Another thing that a lot of people get wrong, the GPS satellites are in medium Earth orbit, which means that they orbit twice per day. They're at an inclination of 55 degrees, which means that the highest latitude they reach is 55 degrees latitude. That means that they're not always stationary over a particular part of the Earth. And I hear some people say it's 31 geostationary satellites. They're not geostationary. That's a huge misconception. Now, NTS-3, our experimental navigation technology, Satellite 3, that one actually will be geosynchronous, and we're looking at, what could you do if you have one satellite that's always in view and then 31 that orbit in and out of your field of view.
That's great. Well, hopefully, you guys learned something here today. And if you have any other questions, please feel free to comment and see if we can get them answered.
All right. Thank you.
Thanks for joining us.
Make sure to follow us on social media at Facebook, Twitter, LinkedIn, Instagram, and YouTube at AF Research Lab. And remember, stay curious.
Logging off.